We've been talking about consecutive integers, and we've shown how we can use algebra to represent 3 of those integers in a row by calling the first one x, followed by x plus 1 and x plus 2. What we're going to look at in this video is what if they ask you to talk about consecutive integers, but they instead add a word right here. Instead of consecutive integers, we're going to talk about consecutive even integers. We're still talking about numbers in a row, and we're still talking about ones that are positive, negative, but no decimals or fractions. But we're restricting that list to just numbers that fall in a row that are even. So if you think back to when you learned to count solely by the even numbers, we're talking about 2, 4, 6, 8, and so on. We're talking about values that are all even numbers, but they're in a row. We don't skip from 2 to 6. We make sure that we get every even number in a row. We could also use negative values. So if we started down here at negative 18, the next in the list would be negative 16, negative 14, negative 12, and so on. Just like we did with the regular consecutive integers, we can use algebra to set up a way to represent consecutive even integers. What we're going to do is let this first value be x. Now let's compare how that first value compares to the ones following it. If I let my value for 2 be x instead, how does the list of consecutive integers change when I go from 2 to 4? Well, there's 2 numbers in there. I'm skipping one. 2 plus 2 is 4. So what I'm going to do is let my second value be x plus 2. Compared to this list down here, if I had negative 18 and I added 2, I'd have negative 16, so it works. The next value in my list then, the 6, is going to be compared back to the original number of 2. 2 plus how many gets me to 6? This time the number is 4. So x, then x plus 2, then x plus 4 in my list of consecutive even integers. And then from 2 to 8 is a change of 6. So my next number would be x plus 6. So if you look at how to represent this using algebra, it would be x, x plus 2, x plus 4, x plus 6, and so on. Some of these problems, instead of saying consecutive even integers, might say consecutive odd integers. How does it change if it says odd? Well, this time I'm not talking about those by counting by even numbers. I'm looking at starting with an odd number and then going to the next largest odd number and then the next largest odd number. So I get this list of odds: 1, 3, 5, 7, 9. I could compare that to the negative list of negative 13, negative 11, negative 9, negative 7, and so on. If I look at how to use algebra, letting my first value be x, how does this first value compare to the next largest odd number? From 1 to 3, I add 2. So now I have x and then x plus 2. Going from 3 to 5, I added another 2. So every time I'm increasing by 2. From 1 to 3, I added 2. So from 1 to 5 is going to be x plus 4. And then x plus 6. Notice that this list matches the one that we just talked about with consecutive evens. So whether the problems say odd or even, we're going to use the same setup for solving them using algebra. We're going to let x be the first number, and then x plus 2, and then x plus 4. And if we need more, we would have x plus 6, x plus 8, and so on.